Today we are doing hard problem find in mountain array. This is interactive problem. You may recall that the array is a mountain array if a recall from where? Recall from where, brah? 3 elements, and it's increasing and then it's decreasing. Minimum index such that mountain array gets is target. If such an index does not exist, return -1. Such an index does not exist, return -1. You cannot access it directly, so we can only get the kth element and length, and we need to do at most 100 calls, and the length is 10 to 4. So essentially the point is that target could be either in this part or in this part, and we want to find this element, and then with binary search by looking at adjacent elements and seeing their slope, and then so we find the last index for this, and then we know there is 3 elements because there has to be at least one this and one this, and then we binary search for target here and binary search for target here, and then whatever. Question is, okay, so logarithm of 10 to 4 is like 10, 11, 12, 30, so like 14, less than 14. So we can do like by 3 binary searches, even 7, 8 binary searches. 7 binary searches, which we are not gonna do. So what? Since when are types in string? That is crazy. You should not speculate about its implementation. Okay. So I guess let's get rolling. What can I say? Okay, so let's say we do the first binary search, and what we control? Well, we check if adjacent indexes are, so if they are decreasing values there, then we for sure have to search here, right? So R is equal to M. Otherwise, if we are here, so in the increasing part, then if we are on a lower element, we want to increase. Okay, so this way we should find, technically we are doing like an upper bound. So n is equal to len mountain array lr 0 and -2, while this mid is l plus r. And now if next mountain array get mid mountain array get mid plus 1 if current over next or current under target. No. mountain array, Java syntax, why not? Target 0, 1, 2, great. And then here it's 0, 1, 2, 3. Yeah, I mean, target would be larger than maximum value. Because, okay, let's say I rewrite this test case to have target 5. Where do we finish? Test result, test case to 0, 1, 2, 3. We still end up here. Okay. So if at that position we have numbers smaller than target, we can return -1 because it's not there. Val, if val equals target, then we return L because that's the soonest index. And only then we do the binary search again. So we can set like R is equal to this. the same thing in the other part. If breath, current, or current is under target or over target, mountain array get L. That should work. Mountain, okay. Yeah, that's pretty easy. Okay. I mean, it was only labeled hard because it's interactive. We can binary search for the idea is to use binary to try to locate both target in the increasing and or the decreasing part. First check the increasing part, and if the target was found, we can return its position early, since we should report the last occurrence, occurrence with minimum index. Approach. Okay, so first binary search will, how can we to look for the target in the first part. In the part we could first locate the position I, the top of the hill, and then do 2 more binary searches to check the parts, but we can combine the first, but in each iteration of the binary search we can look for the two adjacent values and check if they are increasing or decreasing. If they are decreasing, we are in the second half, or the value of the first of the two elements or the value of the first of the two elements is then target. We move the right border of the binary search since midpoint. Otherwise, we move the left border since the value at midpoint is smaller. This way we either find the target or the next greater element in the increasing part, or we find the top of the hill and its value, the max, which is the maximum value of the entire array, will be is smaller than target. In the first case we return the found index. In the third case we return -1, and since target over max mountain array, i.e. target is not in there, we return -1. and in the second case we check the other half of the array. We check rest of the array, and in the second case we check the rest of the array in a similar fashion, but we move the left border if we are in the increasing part, or the midpoint, which is now the second of the two values being checked in each iteration, is larger than target. If finally we return -1 if the value at the final index at the index found by the second binary search is not target, otherwise we return the found index. Of login, since we do two binary searches and in each of them we do O1 work per iteration, asking two questions about array, and there is login. Iterations for both memory. O1, since we only use a couple of extra variables during the searches. Okay, 25 minutes for hard problem, not terrible.